Um, okay, so in this video, I'm going to talk about section 15.3, which is matrix multiplication. In the last couple of videos, I've showed you guys how to do matrix addition, multiplication by scalar, and also subtraction. Over here, we'll do multiplication, which is slightly more complicated. So how does multiplication work? So let's say you have two matrices. You have matrix A, which is A11, A12, A13, A21, A22, A23, and then you have another matrix B, which is B11, B12, B21, B22, B31, B32. Okay, so you have these two matrices. So matrix multiplication means that you're going to multiply A into B, and then you're going to find a new matrix C. So for this multiplication to work, there's two important rules. The first rule is, notice what is the order of this matrix. So this is a 2 into 3 matrix, right? 2 rows, 1, 2, 3, 3 columns. Whereas this one, this is a 1, 2, 3 rows and 2 columns. So for it to be possible to multiply A into B, we must always have the case that the number of columns in the first matrix has to equal the number of rows in the second. So the number of columns in the first, 1, 2, 3, has to equal the number of rows in the second. And so this needs to happen if this multiplication is to work. And then after you multiply that, the resulting matrix C will have a dimension which is equal to the number of rows of the first matrix and the number of columns in the second matrix. Okay, so essentially this matrix C will be something which is 2 by 2. Okay, so how does matrix multiplication work? So the way the matrix multiplication works is, you take this coefficient, you multiply it with this one, then you add this into this plus this into this. So for your matrix C, your first entry is A11 into B11, A11 into B11 plus A12 into B21, A12 into B21 plus A13 into B31, A13, B31. That's your first entry. And the second entry is you do the same, but now with this column. So A11 into B21, A11 into B12 plus A12 into B22, A12 into B22 plus A13 into B32. Okay, sorry, A13 into B32. And similarly, now you have to take now this row and multiply it with this column. Okay, so A21 into B11 plus A22 into B21 plus A23 into B31. And then the second entry would be, the last entry would be A21 into B12 plus A22 into B22 plus A23 into B32. Okay, so this big thing here, once you do all these calculations, this is going to lead you to matrix C. Okay, so let's see how an example works. Okay, I think that might be the easiest way to do this. So the example I'm going to do is, I'm going to do example 15.3.1 from page 589. Okay, so over there we have these two matrices. We have matrix A, let's say, okay, which is equal to 1, 0, 3, 2, 1, 5, and then you have another matrix B, which is equal to 1, 3, 2, 2, 5, 6, 2. Okay, so you have these two matrices. So again, first let's check, can we multiply A into B? So this is a matrix which has 2 rows and 3 columns. This is a matrix which has 3 rows and 2 columns. So notice that the number of columns in this is equal to the number of rows in this. That means, yes, we can multiply A into B. Okay? And then the matrix C, which is going to be the result of the multiplication, will have a dimension which is equal to 2 into 2. Okay, so what will matrix C look like? 1 into 1 plus 0 into 2 plus 3 into 6. That's your first entry. The second entry is 1 into 3 plus 0 into 5 plus 3 into 2. Okay, then you move to this row here, 2 into 1 plus 1 into 2 plus 5 into 6. And finally, the last entry is 2 into 3 plus 1 into 5 plus 5 into 2. So if I simplify, if I do all these calculations, I'm going to get a matrix which is 19, 9, 34, 21. So this is the matrix C, or the result from multiplying A into B. And notice that what is the dimension of this matrix? 2 rows and 2 columns, right? Which is what we also sort of predicted when we were doing this. Okay, so this is the bit on matrix multiplication, and then I'll do a few more examples in the next video.